Hello geometry students, this is Mr. Butterball. Welcome to our next lesson. It's titled 3-4 Algebraic Proofs. And we're going to go through a couple properties of equality and congruence first in order to use them for proofs. So let's get started. First, like I said, those properties of equality and congruence, these are things that you already know. I guarantee you already know these things. Now we just put a name to them. The first one is the addition property. If I have an equation and I add the exact same thing to both sides, that's called the addition property. So if I have a plus c, that's equal to b plus c. I add the exact same thing. If I subtract the exact same thing from both sides, it's a minus c, b minus c. If I have the multiplication property, if I multiply the exact same thing on both sides, so a times c is the same thing as b times c. I would just multiply, and c here is a constant. That's why we're saying c. I'm just going to multiply or add or subtract or divide here, the exact same thing. So divide, the division property, and then a divided by c is the exact same thing as b divided by c. And again, you've already seen this. This just comes into play whenever we actually prove what we're doing. All right, the distributive property, you know what distribute is. If I have a times b plus c, I can distribute that a to the b and the a to the c. So that's going to be equal to a times b plus a times c. Again, the distribution property, distributive property, you already know it. The substitution property, again, you already know this. If a is equal to b, then b can replace a. So if I have an equation or if I have an expression and it says that something is equal to x, then x can replace what that something is. Alright, so why do we have you guys write that stuff down? Why do we talk about the addition property, subtraction, multiplication, division, distributive, and substitution property? Why? Well, so when we're talking about how something is proved, or if we're proving something is true. So here's an example of a two-column proof. I want you to pause the video and write down this two-column proof, the given statement that we have, and that we're going to prove x is equal to 18. Okay, in this example, we already have an equation, and they've already told us what the answer is. We just want to go through the steps and prove that it actually is those things using these properties of equality. All right, the very first thing that we always start with a two-column proof is always the given. You can put that first on the right-hand side for reasons, is always given. So then on the statement, you want to write down the statements and the steps that you take. So what is the given? It's 2 times x plus 7 minus 1 is equal to 3x minus 5. That's our given statement. Okay, you might know, or you should know, that our first step to solve this equation is to distribute the 2 to the x and to the 7. So I can do that, and I'll get 2x plus 14 minus 1 equals 3x minus 5. All right, and why did I do that? What's the reason? We just simply put the distributive property. All right, and what would be our next step in solving this equation? That would be to combine the 14 and the negative 1. So I'm going to say 2x plus 13 is equal to 3x minus 5. Okay, what did I do there? Well, all I did was simplify. So that's the simplification is my reason for doing what I just did. Okay, the next step in solving that algebraic equation is going to be to get the x's on one side of the equation and the numbers on the other side of the equation. I like to get my x's on the left side, so I'm going to bring it over. So I would subtract 3x from both sides. You would not have to write this down if we're actually going through our two-column proof, but so we can see it, I do. If you have trouble seeing this, please write it down. Do not skip this step if this is still trouble for you. So 2x minus 3x is negative x, and I have that positive 13, so negative x plus 13 is equal to, these cancel out, is equal to just leftover negative 5. Okay, why can I do that? Well, I subtracted, so that's simply the subtraction property. And yes, I want you to write down subtraction property, because it's actually called the subtraction property of equality. I'm being nice by saying subtraction property will suffice. What's our next step? What's the next thing we do to solve for x? We bring that 13 over, I subtract 13. So I have negative x the 13's cancel out, is equal to negative 5 minus 13 is negative 18. All right, again, I did the subtraction property. And lastly, I'm going to solve for x. I'm proving that x equals 18, not negative x equals negative 18. So my last step is going to be to divide by negative 1 on both sides of the equation. So I left with negative x divided by negative 1 is x, is equal to negative 18 divided by negative 1 is positive 18. And I do that because of the division property. So there you have it. I have x equals 18. That's what they wanted us to prove. So we can do that in a two-column proof, listing it out step by step. This helps us into geometry, number one, to see things and how they work and how we get to the answer. But also when we apply this to diagrams, we can do this step by step. It's a way to, number one, check to make sure we're doing it correctly. But number two, give a reason for what we're doing. So the reasoning and proofs and logic and all that stuff comes back into place. All right, if you need to rewatch this video for any reason to get the points down or to understand exactly what I did in the two-column proof, please do that. Bring this to class tomorrow and we have some practice.